Right, a bullet is fired with a speed of 300 meters per second at an upward angle of 45 degrees from the top of a 280-meter high cliff. Calculate the speed when it strikes the ground at the base of the cliff. Right, let's have a look at this in a more realistic way. Right, the first thing that you need to understand is you must do a drawing. Like for these types of questions, it's a requirement. Right, so let's start with number one. Right, that's the base that we're working with, the flooring. Right, from here, we need a hill. So the hill looks something like this. Got my hill. My height here of my hill is 280 meters. There. H is equal to. Right. My person is standing here with my bullet, and this bullet is going to leave at 45 degrees. So parallel to the base, right? Parallel to the base, oops, I'm going to draw a little dotted line, and that's what that looks like. Right, parallel to, that's the base, and 45 degrees upwards, 45 degrees upwards, we're looking like there. This is how the bullet gets shot, in that direction. Right, just take that away. Okay, so the degrees there is 45 degrees, and that's the way the bullet's gonna go. Right, the V initial here is equal to 300 meters per second, and the bullet's gonna go all the way and do something like that until it gets here to this point here when it's at the base, and they want that speed. We don't know that, right? Again, here with the masses or whatever, they may or may not give that to you, so we'll go with that. All right, so let's have a look here. So the first thing we're going to do is we're going to write down our formula, right? So I know that EM1 is equal to EM2. In terms of mass, because we don't know the mass, what I'm going to do is, when I start, I'm going to start with mgh initial plus half mv squared initial is equal to mgh final plus half mv squared final. Right, in this whole thing, I'm going to divide everything by the mass on both sides, and the masses are going to all cancel out. So now I'm left with gh initial plus half mv squared initial is equal to gh final, oops, it's a subscript, gh final plus half half v squared final. All right, so we got rid of that m because it's the same object. All right, let's fill in what information we do have, right? Essentially, when I start off this whole sort of setup, I'm at a height, I've got 9.8. So don't forget your G value at 9.8 meters per second squared, right? Multiplied by the height, which was 280, plus half. The V initial was 300 meters per second squared, is equal to, now the G at the bottom, I mean the height at the bottom was 0. So that's 9.8 multiplied by 0, right? Plus half VF squared, because we're looking for that VF. So what I'm left with now, I've got 9.8 multiplied by 280. That's going to give me 2,744 multiplied by, not multiplied, added to 300 squared times 0.5 or half. And that's going to give me plus 45,000, which is equal to 9.8 times 0, which is 0, plus half VF squared. Right, so 45,000 plus 2,744 is going to give me 47,744, which is equal to a half VF squared. Now I need to get rid of the half, so we're going to divide both sides by a half. And this will cancel. And I'm going to be left with, just going to move up here a little bit. I'm going to be left with 95,488, which is equal to VF squared. But remember what I said, I don't want squared. So I'm going to square root both sides. And this is going to cancel out. That's going to cancel out that. And VF is actually going to be the square root of 95,488 is 309.01 meters per second in the direction of motion at the bottom, or rather at the base of the cliff. Oops. And that's my final answer. So have a look here. This was important because you can do something like that if you don't know the mass. If you do know the mass, you have to write on the mass every single time, right? You're not getting marks here, right? This is us just getting rid of the mass so that it's not something we have to do later. So remember, each time I do an example, I'm simplifying the situation just a little bit better. All right, so let's have a look at the second question. So I'm just going to move this page up and put in the second question. All right, let's have a look at this question. It says you run with a speed of 6.0 meters per second. You grab a rope hanging vertically from a tall tree. So we have our tall tree over here. And our tree has all of these branches. And that's your tree. Great. All right. You grab a rope hanging vertically from the tree. So here's your rope. And what this rope? Right. And you're going to grab onto it. So here you are here. And you're going to run. And you're going to run and you're going to grab onto this. And when you grab onto this, you're going to swing. And when you get to your highest point here, you're going to stop. And then you're going to swing all the way back. So what you're forming is a pendulum. All right, so let's look at what facts we have. In terms of mass, because we're working with one object, we don't have it, but we also know that we can divide by the mass. Because the question is asking how high can you swing upwards? We know that your initial height, you're on the ground, which is 0 meters. Your final height at the top, we don't know. We need to find that. Your V initial is 6.0 meters per second, so 6 meters per second, and your final velocity, well, V final is 0 meters per second. How do I know that? Because we are dealing with, let's do it here, we're dealing with that point over there. And at that point, you have to stop in order to swing back. And you'll have like a pendulum sort of situation where you're going back and forth and back and forth. All right, so let's have a look at how we're going to set this up. First, I'm going to say EM1 is equal to EM2. And I know some information because I know that EP initial plus EK initial is going to give me EP final plus EK final, right? In terms of the initial, the height is 0. So I know that this EP value is going to be 0 joules. But I know I have a velocity, so I must have that. I know that I'm going to reach a height, so my final, because I'm going to have a height, I need to have that. But at the top, my motion is going to be 0. So my EK final has to be 0 joules. All right, so I'm going to say 0 plus half mv squared final is equal to mgh, initial is equal to mgh final plus 0. Now I'm going to make sure that I divide both sides by m so that I don't have to deal with that. So now I've got half V initial squared is equal to GHF. Right, and all I have to do is solve for HF. So I've got half 6.0 squared. So I've got 6 squared, which is 36, times a half, which is 18. And I've got 9.8 times HF. So on this side, I've got 18 is equal to 9.8 HF. Divide both sides by 9.8 so that we can get the HF by itself. And I've got 18 divided by 9.8, and that's going to give me HF is equal to 1.83673, etc. So HF is actually 1.84 meters high, or at the top. All right, so at the top, the highest level you're going to reach, your highest vertical level, is going to be at this point here. The height is going to be equal to 1.84 meters. All right, does that make sense? So there's your answer, and that's how you sort that out. All right, the next one says, does the length of the rope affect your answer? Explain. All right, so at this point, I can see that, so this is for B. At this point, I can see that if I wanted to calculate the height, the formula would be H is equal to the V initial squared all over 2 times 9.8. That's what that would look like. So all I've done is, if I look here, look at this formula here. That's the sort of setup that I have. So now we can see that if I'm going to run towards this sort of situation, right? I've got my vine over here, or my rope here, right? I'm over here. And I'm going to run towards this area here, right? This vine is connected here, and then I have my tree, which is over here. It's part of the tree or whatever, right? Okay, there's my setup. And this tree over here, or this vine, is a specific height, right? That's a set situation, because I'm going to swing from here to here. And that height, or rather, let's come away from there. I do it another color so you can see it a bit better. I'm going to swing from here to there. And that's sitting at 1.84 meters. Okay, so I've got that sort of setup. I'm going from point A here to point B there at 1.8 meters. So what they were asking here, does the length of the rope affect your answer? So we can see that for height, there's only two things that depends on this height. In order to work out this height, you needed an initial velocity and you needed gravitational acceleration. So the motion is only affected by an initial velocity and gravity, or the gravitational acceleration. Right, now think about it like this. In this situation, I was moving at 6 meters per second. What happens if I was moving at 100 meters per second? Would I go higher? Yes, because if I'm moving faster and I catch on to this thing, I'm going to end up doing something crazy like that. I'm going to end up over there. If I had 100 meters per second. So the faster you go, the higher it moves. So speed or velocity is directly proportional, to height. Can you see that? There's it there. Where am I getting this formula from? Look here. When I wanted to work out this here, how would I have done that? Right? I would have said HF is equal to a half times 60 squared over 9.8. And a half divided by 9.8. So technically what I've got now, not 66.0, I've got HF is equal to 6.0 squared all over 2 times 9.8. So I'm getting the formula from here. That's making height the subject of my formula. So I can see here that height and the initial velocity are directly proportional. But the gravitational acceleration, so 2 times the gravitational acceleration, is directly proportional to 1 over the height. So here I have an inverse relationship. Remember we did relationships? How do I know it's inverse? One is at the top and the other one is at the bottom of the fraction. So those are your two relationships. So you can say and make a statement that the angle or any length, the length here and the angle there, do not affect the height, because the height is only dependent on the velocity, and that's the initial velocity, and the 2 times the gravitational acceleration from this equation that we got from here. So this is what we call an advanced example, or something that's quite intense. So when you make sure that when you're doing these types of questions, you take into consideration relationships, formulas. You have to see beyond what's actually happening. All right, let's have a look at this question. It says, solve this problem without calculations, justify your answer. Choose the correct option. A roller coaster has a speed of 5 meters per second when at point A. So at point A, it's 5 meters per second. 45 meters above the horizontal. When it arrives at point B, 30 meters above the horizontal, its speed is, so we're looking for its speed there. Right, so remember, when I'm looking at these sort of questions, the first thing is, if I have a height here of 45 meters versus a height here of 30 meters, and we've seen it in previous examples, if they're saying the velocity here is equal to 5 meters per second, remember, the elevation here is quite high. So your EP value is quite high. Now, when the EP decreases, the EK must increase, right? In this sort of situation. So if this is going to go down, then this value must come up. It's a relationship type of question. So if the value is here at 45, at 30, it must be greater than 5. So if I look at the answers, I've got A at 2.5. Oops, let's just go back. It's written there. I've got A at 2.5, so it can't be A. I've got B at 5, which is already at 5 at 45, so it can't be that. I've got C at 0, can't be that. So your only answer you're left with is D. So at 30 meters, the velocity is equal to 18 meters per second. So this relationship here, you need to make sure that you write down. That if the EP decreases, then the EK increases. If the EP increases, the EK must decrease. It's like uphill and downhill, right? So make sure you understand that type of a relationship. Right? If I'm looking at 1B now, 1B says, if the roller coaster has a speed of 80 meters per second at point B and moves in the opposite direction towards the 45-meter hill, will it reach point A? If yes, calculate the speed at point A. Right, so this is a bit of a trick question. Oh, so they're just trying to confuse you with the words, but let us not get trapped. Right, it's now doing something that's a little bit different. It says the roller coaster has a speed of 18 meters per second at point B, and it moves in the opposite direction towards the 45-meter hill, which is at point A. So we want to know, will it reach point A? Now, in order for it to reach point A, remember, look here. I'm going from B and I'm going all the way to A. So here, my EP is going up. My EK has to go down. So we're going in this direction here. Now, in order for us to reach A over here, your answer must be greater than 5 meters per second. So now B is actually our initial, and anything to do with A is our final. All right, so let's get information down. All right, my V initial is equal to 18 meters per second. My height at that point is 30 meters. My G value is equal to 9.8 meters per second squared. All right, my V final, I don't know. So this is for everything to do with B, and this is for everything to do with A. My height over here is 45 meters. My G also still 9.8. And mass we don't know. Oops. Mass we don't know, so we can factor it out. So let's start. I'm going to go EM at B is equal to EM at A. So I've got MGHB plus half MV squared B is equal to MGH at A plus half MV squared A. Alright, so I'm just going to enlarge in this so that we can see it a little bit better. Alright, I'm going to factor out the mass. Let's cancel all of this. And I'm left with GH of B plus half V squared B is equal to GH at A plus half MV squared at H. Or not MV squared. Half V squared at A. Right, the G value is 9.8 multiplied by a height of 30 plus half times 18 squared is equal to 9.8 oops, multiplied by 45 plus half v squared a. Alright, so nice and simple. The first one is 9.8 times 30 is 294 plus 18 squared, 324 times a half is going to give me 162 is equal to 9.8 times 45, which is 441 plus half v squared a. All right, I'm going to take this over and I'm going to have 294 plus 162 minus 441 is equal to half v squared a. I pop all of that into my calculator. I'm going to get 15 is equal to half v squared a. All right, same thing. Get rid of that half by dividing both sides by half. And technically what I've got here is 30. Which is equal to v squared a. Now I don't want v squared, I want v. So I'm going to square root both sides to get rid of the square. And the square root of 30 is then v a is going to be 5.48 meters per second. Alright, so what I'm looking at now is that I can understand that the roller coaster will reach A at a speed of 5.48 meters per second. So remember the speed at A was 5 meters per second, and I said it must be greater than that. And can you see? It is greater than that, so it means that when it came from this point here, B, and it went down and it had to reach A, which was up there, it had to overcome this hill over here, this portion to that portion. And the only way it could have done that, because remember, when it overcomes this hill here, it at this point it's 5 meters per second. Sense? But when it has to overcome this hill, remember it's going to slow down to get to that point. So because when it's going from this point to this point, this has to be faster than the top. Alright, so there's your final answer there. Alright, let's have a look. You can see that I'm doing quite a few examples for this section because it is relatively more complicated. So please do the examples with me because later on only you will benefit from this. Right? Let's look at the next question. The next question is the pendulum. Okay. It says here, calculate the minimum speed of the swing of the pendulum bob at the lowest position A for it to reach position B, which is 1 meter above the lowest position. Right, so they want that. So they want the initial. So let's have a look at that. I'm just going to add the question here to this part of the paper. Alright, let's start sorting out our information for something like this. Alright. So, at point A, what do I know? I know that the velocity at point A I don't know it. So we need to find V initial. Right. I know about the height, it's equal to 0. And if it's equal to 0, then the EP is also equal to 0 joules. I have a G value, which I'm not even going to use. Meters per second squared, because the EP is 0 joules, because there's no height. Right, we're looking for that value. At point B, the V final in this sort of question that we're looking at. Remember, when it gets to that point, the V final is 0 meters per second. And if the V final, because remember it's going to go till there. And when it gets to there, it has to turn around. So when it gets to this point, it has to stop. And then it will swing all the way back and do something like that. So that's how a pendulum works. So we know now that the velocity at the top there at point B is 0, which means the EK at point B is equal to 0 joules. So the EP at A is 0 joules and the EK at B is 0 joules. The height there is 1 meter and the G value there is 9.8 meters per second. Right, notice the mass again. They don't give us the mass, but it's the same object, so we can factor it out. We can get rid of it. Right, so we start with EM of A is equal to EM of B, and we're looking for V initial. So I'm going to say EP at A plus EK at A is equal to the potential energy at B plus the kinetic energy at B. This value here is 0 and this value here is, they both are 0. So 0 plus half mv A squared is equal to mgh for both plus 0. For both of these, I can take out the m, gone, and I'm left with half v squared A is equal to GHB. And what I'm looking for in this whole thing is this V value here. Right, let's put in the information. I've got half V squared A is equal to 9.8 multiplied by 1. So I can divide that by half and divide this by a half. And what I'm left with is V squared A is equal to 9.8 divided by 0.5, which is going to give me 19.6. But remember, I just want the velocity, not the velocity squared. So VA, or the initial velocity, is the square root of 19.6, which should give me 4.427188, etc. So V at point A is 4.43 meters per second in the direction of motion at the lowest point of the pendulum. Right, and that is how you would work out something like that. So please make sure we follow some of our rules. Can you see how important it is for me to write down info? Because it shows me what I'm looking for, it shows me for what I have. I make sure I write down this formula, I expand, I factor out that M, I get a proper formula that I can substitute into, I substitute. Don't forget this step for square rooting, because we're not looking for V squared, we're looking for just VA, and this is the speed at point A. All right, I've got one more example. It's a bit lengthy, but remember, you're doing this with me, or you're working through this with me so that it can benefit you at a later stage. Right? So I know it's quite lengthy. Please make sure that you're writing down these questions, you're drawing these diagrams. All of this is sitting in your books. Right? There's no point in having all the working out if you haven't written down a single question. All right, let's have a look at the next one. All right, this is going to require quite a bit of calculation, so let's kind of work together. Right, it says a roller coaster has a speed of 1.80 meters per second at point A. So for point A, the velocity is equal to 1.80 meters per second. And the height at that point is 30 meters. Right. Assuming no friction, calculate this speed at point B. Great. Point C. And point D. Okay. All right. So at point B, the height here is 0. At point C, the height is 25. And at point D, the height is 12 meters. All right, so what we're going to do is I'm going to work with A and B. All right. Once I'm done with A and B, because I can work with this A and B information and I can find B, the velocity of B. Then I'm going to work with B and C. And then it's going to help me to find the velocity of C. And then the last thing I'm going to do is I'm going to work with C and D. And using the information that way, I'm going to end up doing 3 types of calculations. I know in all of these calculations, mass must be the same, so it can be factored out. All right, so I'm going to start here. When you do a calculation like this, please make sure that you show your marker what you are doing. So the first thing I have to tell my marker is I'm looking at point A to B. So I'm going to do that calculation first. So I've got EM1 is equal to EM2. That's my setup here. Right. I do know that in this calculation, because my height is 0 here, then for EM2, my EP is equal to 0 meters. Right? And I'm looking for the velocity at point B. That's what I'm looking for. For EM1, I've got both the kinetic and I've got a EP that's greater than 0 and I've got an EK that's greater than 0 because I've got height and I've got velocity. See, height and velocity. All right, so I'm going to go MGH A plus half mv squared A is equal to half mv squared B plus 0. Right, or 0 plus, whatever the case is. Then I take out the mass, so I'm left with GHA plus half V squared A is equal to half V squared B. Right, so my actual formula is this one, which I'm going to be substituting here. Here I divided by M. That's how I got that. So I'm going to go 9.8 multiplied by the height at A, which was 30, plus half with 1.8 squared is equal to half times V squared B. Alright, so I know at this point 9.8 times 30, I've done this calculation multiple times, is 294 plus 1.8 squared. And then don't forget to multiply that by 0.5 or half, right? And you're going to get 1.62 there is equal to a half V squared B. All right, what I'm going to do is I'm going to divide both sides here by half. Oops. So that whole thing divided by a half is going to give me 591.24 is equal to V squared B. But remember what we said, we don't want the squared, we want the actual velocity. So I'm going to take that value, I'm going to square root it, and I'm going to get VB is equal to 24.32 meters per second. Alright, so I'm going to go back here. And over here, I'm going to fill in this at 24.32 meters per second. All right, now that I've got that information, I can start working on BC. All right, let's do that in another color. I didn't red. All right, so for this one, I'm looking at point B to point C. All right, in this sort of situation, I've got the same setup. EM1 or EM of B is equal to EM of C. For EM of B, I know the velocity. I know that I have a velocity, so I have an EK that's going to be greater than 0. But because it's on the ground, my EP must be equal to 0. For C has a height, so it has an EP greater than 0. And it has velocity, which we're going to look for. So we know the EK is greater than 0, and we're looking for VC, essentially, then in that situation. So the height for C is 25, and the height for B is 0. So I'm just going to write that information down here. The height of C is equal to, what did I say? Sorry, 25 meters. The height of B is equal to 0 meters. G is equal to 9.8 meters per second squared. We're looking for V of C. V of B is equal to 24.32 meters per second. All right, I've got all of that information. All I have to do is now put it into my calculation. All right, so I know here that it's going to be 0 plus half mv squared b is equal to mghc plus half mv squared c. I'm going to take out the mass, so I'm left with half v squared b is equal to GHC plus half V squared C. All right, half of 24.32 squared is equal to 9.8 multiplied by 25 plus half V squared C. So I'm going to take the 24.32 and I'm going to square it. And I'm going to times it by 0.5. And that's going to give me 295.62 is equal to 9.8 times 25, which is 245, plus half V squared C. I'll take the 245 to the other side. Wait, where am I? I've got 295 minus, 0.62 minus 245. 245. And that's going to give me 50.62 is equal to half V squared C. All right, divide both sides by half. And I'm going to get 101.24. 101.24 is equal to V squared. But like we said, we don't want V squared. We want V. So I'm going to square root both sides. And I'm going to get V is equal to, VC, is equal to 10.06 meters per second. Right. So that's the next thing. So I'm going to go back up here. And I'm going to say that this is 10.06 meters per second. All right, so now I've got that information. Once I've got that information, I can now work with C and D. So let's go and have a look at that situation. So that was point B to C. Make sure you get this information written down. Right. Point C to D. Right. I've got EM of C is equal to EM of D. Right. In terms of point C had a velocity, so it must be greater than 0, the kinetic energy. And because it had height, the potential energy must also be greater than 0. Point D has a height now. Does it have a height? It has a height of 12 meters. Good. It has a height, so it means that its EP value is greater than 0. And it has a velocity, because that's what we're looking for. So it means it has an EK that is also greater than 0. And what we're actually looking for is VD. Right. So let's get our formula written down. We have to use all of it. So I'm going to go mgHc plus half mv squared c is equal to mgHd plus half mv squared d. Great. Right. Mass I'm going to factor out, so I'm left with GHc plus half v squared c is equal to GHd plus half v squared d. Right, I've got 9.8 multiplied by, for C, sorry, I should actually have written this down. My height for C was 25 meters, but my velocity was equal to 10.0606 meters per second squared. Meters per second. My height for D was 12 meters, and my velocity for D is unknown. Okay. So I've got a height here of 25 plus half. My velocity was 10.06 squared is equal to 9.8 multiplied by 12 plus half v squared d. Alright, so I've got 9.8 multiplied by 25, and that's going to be 245 plus 10.06 squared times 0.5 is going to give me, 10.06 squared times 0.5 is going to give me 50.60 is equal to 9.8 times 12, and that's going to give me a 117.6 plus half v squared d. Right, I'm going to take this over, and I've got 245 plus 50.60 minus 117.6. And I've got here on the side 178 is equal to a half v squared d. Divide both sides by 0.5 or half. That's going to cancel. And I'm going to be left with v squared d is equal to 356. Remember, I just want the velocity, so I'm going to get rid of the square. I'm going to square root my answer, and I'm going to get VD is equal to 18.87 meters per second. So don't forget, in the direction of motion, in the direction of motion. I I need to make sure I write that every single time. So that would have been the last little bit. In the direction of motion. And then come up here and I could write this down as 18.87 meters per second. And there I've done the calculations. There's my answers. So I've done points A to B. I did points B to C and C to D. And I got all three of my values. And I have it all here. There we go. So when you do these types of calculations, please make sure you draw up this little thing. It helps quite a bit. Sort this information out. Get these final formulas where you factored out the mass so you can substitute into those formulas. Make sure that when you have these formulas, you're substituting the right values in. This is the most important thing that you may forget. Make sure you square root it. Just like how we do with Pythagoras and stuff. I know it's quite a lengthy video, but once you're done, you're going to go and do worksheet 1, and then you're going to do worksheet 2. And then when you're done here, please send solutions to me. Please, 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 I cannot stress how important it is for you to do worksheet 1 and 2 for this section. It's such an important section in your paper. The bulk of your paper is motion and the stuff. So please make sure that you are prepared. All right, and that's the last topic done for physical science grade 10.